Alright, so here I'm just going to talk a little bit about the assembly of the lighting that I have. So as you guys can probably see, I am using 2 LEDs instead of 1 here. So here's the wiring arrangement that I have. I start with, since these are in fact directional, so on here you should be able to see the little arrow that's right about there that shows the direction that the data must flow in order for them to be addressable. But here, so we get our starting one, our male end of those servo connections that you talked about. The 3 ports there flows on through and then goes to these. So I've been assembling them by making one good one. So here's my example one that I made that fits perfectly inside of the regular squares here, or they're triangles, I guess. Moving on, I then use that to make a whole bunch of copies here. So the next thing that I'm going to do is I'm going to take these ends and tin them, and then the same thing for these. I'm not really going to describe how to tin them because, well, anyone can Google that. Anyone can Google that. So these are actually already tinned. I'm going to tin the rest of them and then solder them up. So what you want to do is you want to start from one end and then go through, making sure that the arrow is in the right direction of flow. Again, starting from the male end of the servo connector and going to the female end. Alright, so now that we are all wired up with all of these, just another double check that the small arrows focus. It'll get there, I swear. Alright, so that the arrow right by the LEDs flows, so flows as in this way, from the male end. Check the next one. Okay. Check the next one. Okay. All the way to the female end. So that way we make sure that it can flow, because otherwise if you get one reversed, you won't be able to hook it up, and that's a bad thing here. And then just another hint is that when every time I solder them, I give each end a little wiggle. People that are better than me will put heat shrink on these ends to make sure that they stop from flexing. But I just mainly check to make sure that the solder joints aren't touching. So as you can see, they're pretty gnarly. But you know what? If it works, it works. And these are stationary once installed, so screw it. Next step is going to be hooking them up to the. I'm gonna adjust my camera here. Forgive me. Hooking them up to the controller. So I know that this is probably something that a lot of people are going to have questions for, and I guess I'm here to oblige. So on here is the ESP 8266 chip on here, so right in the middle. And the setup I have here, well, I'm sure it looks complicated, is that I have a power supply located over here. It's actually not plugged in, but I have my 5-volt power supply here that I will plug in a little bit. Power supply that comes in on this red and blue, so positive and negative, which then delivers it to this rail here. So I have this green wire going to power connected to the V-in. The V-in, it says so on the chip. I'm not going to zoom in for you because it's annoying. Actually, hold on. I have a spare. Always have a spare. So what you want to do is you want to connect power to the V-in there. You want to connect ground to ground. Pretty straightforward in my opinion. And then the other side, if you rotate it around, you'll take a look, and the stock pin is a D6. So that's the data pin. It's a digital pin, and you want to connect that to the data on the LED strip. What am I talking about with the data on the LED strip? Well, if you get the strips here, so this is just the the base strip that we just cut apart, you will see that, excuse me, there's 5 volt plus 5, so the plus 5 from the power supply, like I was talking about. Then there's focus. There's a DIN, so that's data in, and then a ground. So that the D6 pin is the one that you're going to want to hook up to the middle pin there, and then positive and negative, which should be pretty straightforward. So anyways, back to my board. I do have the power supply connected right here. This is the same jack that we'll be using when we build the Moodlite. So anyways, if we can see on this wonderful tiny board, I do have positive and negative, so the yellow goes to negative, green goes to positive. I also have a positive wire here that is going to connect to nothing. Apparently that's extra. There we go, perfect. I'll edit that out, and by that I mean I'm just going to release this normal. And then this red pin here is the one that I was thinking about. This red wire here is the data lead that goes in the middle of this hastily cobbled together female port. So once I plug it in, this board will turn on and we'll start loading the software. How do you flash the software? I use the Arduino, the Arduino IDE to just flash it. You just plug it in via USB. You have to install a couple libraries. Just Google it. If you can't find it, I'll probably try to post some links down below for the stuff that I use, but it's fairly straightforward from my experience, but I might be a little more experienced with my 3D printers and other Arduino fun things. So anyways, now that we have that, I will plug in the power supply. Alright, so hopefully you guys did see that thing blink over there. So now this should be running, and we are going to check each strip individually. This just helps us know whether or not we fucked up. So we can fix it from there. Just pay attention to any sort of flickering or any smoking obviously coming from there. I have shorted that before, so it's a pretty hardy unit, honestly. But as you can see here, they are working and they are eventually changing colors, which is exactly right. So if you have flickering, that means that your data pin is not configured correctly, or something is wrong with the board. It's not receiving enough power, or something kooky. If they don't turn on, or if they're dim, that's just your power supply, or the fact that you changed the brightness settings in the default script. So it looks like this cable is good, and we'll just run through and do the same thing for the rest of the cables. Fortunately, I need to work on my stand-up comedy here, so you just have to listen to me talk a little bit. So it looks like all 3 segments of this one are also working. So move on to the next. This is a pretty cool project. It's the first one I've ever worked on using addressable LEDs. I thought that I would have to learn how to use MOSFETs. Because I was actually used to working with RGB or RGBW strips like this, which have 4 here, and it actually has a separate driver for each LED instead of just being given data and then outputting, because basically it's expecting the controller to be outside of the. I'm sorry, really sorry about the whole focusing nonsense. I'll zoom. So it requires a driver for each one of these. There's no chip. Instead, the LED is just, each one of those. And you have to drive a 12-volt signal, which is hard with an Arduino. They don't have large enough MOSFETs to typically feed these properly, especially at 12-volt. Whereas the advantage of these 5-volt WS something or other chips is that on the circuit board, you see that little black portion there? That's actually the chip that takes the data through this D-in. That's why this one just has a separate D-in, and then it uses that to control the brightness and everything like that. I may talk about in a later video using like a pie to control a strip, similar to this one here, without it, because that's what my computer uses and all the other stuff. But hey, what do you know? So anyways, moving on here. So we're going to connect this one in, making sure to watch for any sort of magic smoke, because once you let the smoke out, don't come back. Okay, that one looks pretty good. And then this one, if I haven't already checked it, maybe I already checked it, who knows. But everything is good. So next step is to hook them up into the unit itself. Alright, so now all we need to do is assemble the wiring into the thing here. So looks like I forgot to clean out some of these supports, which is perfectly fine here. I'm sure everyone will forget to do that eventually. So anyways, I'm really quite pleased with the V2 updates. I had actually made my own update before it was suggested online. The red is from leftover stuff on my build plate. So this is actually one that I cut out myself and I filled in the other ones, which is why it doesn't have the wire retention features that are added, which is nice. But anyways, so thankfully it's a pretty darn simple loop here. The male end will be fed here and will sit in this cavity. So you can see that's kind of a cavity. Might have to clear that out with a utility knife, X-Acto. But it routes around. It'll go around in a circle, come out the other side, go in here, go around in a circle, come out the other side, and then go with your left or right for your other connections. So it's actually pretty simple now, instead of some loop-de-hoops and other junk that didn't really make much sense when I was looking for it. Yeah, which is fairly important. So let's just clear that out. Looks like I broke that top piece there, but that's okay. It's bolted to the wall, no one will know. Except for you, the viewer. Curses. Or we'll just make this one a right versus a left. But anyways, getting to the wiring. So like I said, all we'll have to do is start with this here, loop that through, give it a certain length. So I've done a lot of playing, so I've already figured out the right lengths, so I can actually do it by positioning the LEDs inside of the chamber and just routing them down, and then I can worry about the retention features later. So honestly, you just put that in there, position your LEDs, and keep moving along. When we're done, we will take a look at the solder position to make sure that they haven't bent and gotten in contact with one another because of our bending, and it looks like I was a bit generous when I made these, which is, a-okay, or it's the fact that we are letting them farther out. That's probably it. So then you just fish the, sorry, you've been staring at a mostly empty workbench as I bring it into my body here, but and route that down. So now that it's been routed all the way around, we can do some adjusting here. So I'm gonna push that back, move that around, push that in as much as I can, push these ends back to make them flush against there. Same thing here, try to center these LEDs. I'm trying to decide between a single center post in the middle or two side posts like I had originally tried. The two side posts are harder to get in, but probably make it a lot easier to organize and make sure that the wires stay. So one of the things that we want to do here is first make sure that this junk gets out of here, and then second, just make sure that those wires aren't touching anywhere so you cause any shorts. It's only 5 volts, so it's not going to like burst into flames or anything. But I mean, you could short out your stuff and kind of be sad while you wait for parts or that kind of stuff. So honestly, that's really it for these. You just wrap this around. You have to clean out that chamber if you want it to tuck, and then you can do the same thing here. So literally just take this, run it along the back, really put some support in there. Ugh. I probably should just print the underside without any support and just use bridging, just for convenience sake at this point. But so yeah, just route it and then run it to, we're going to run it to this side today for funsies, and then just kind of tuck it in and through if we didn't have any junk in the way here. So that's that. Next step is to so you can do this on every single one of them, and then the next step is to wire the control box. Taking a short break from working in the shop, we have here a wonderful smoker, and oh, looky there, that's a nice duck. You gotta make sure it's safe to eat and all. Oh ho ho, she's looking done to me, boss. Get a couple more pokes in there. Oh, looking real good, looking real good. Oh, I'm gonna have some of this and then get back to work. So for the control box, I'm actually honestly kind of confused on how the original designer intended to wire this, because when you put the chip in, either way, it's the same way either way. You don't have really any room to connect the wires because the pins go in this nice little slot, and you're pretty much SOL, honestly. You can't get any wiring in here. Don't mind the print. I accidentally printed this on my PET-G settings, which is at 250, and this is a PLA. So honestly, it did as good as it could for what it was for the original one. So I actually took the original file, as you can see, much better looking here. Still a little rough, but and I lengthened the bosses here. So I raised them up a little bit, and I made the top a little taller as well. So it's a larger unit. It doesn't, not going to look as pretty, but it at least allows me enough space underneath the, excuse me for out of frame, allows me enough space underneath there to get the wiring. So like I was talking about before for the wiring, what we are looking for here is we need to connect wires to the VIN, ground, and the data. And then so what's going to come in here is the power. So that's going to be a single bullet connector, like I showed before. And then this is going to be output. So it's just going to be a female connector, because we start with male. And that will have a 5-volt data, ground. And I'll just go out and then connect it. So I'll get the material set up, and then we'll film assembling that. Alright, so here we have the assembled control node. So what we have here is our focus. Sorry. What we have here is our 3 pins, the voltage in, voltage out, so VN plus ground, and then our data pin here in red. So we have those hooked up. Like I said before, I lengthened it because I have no idea how they got the pins in, since I had to still smash mine to get them in. And by smash, I mean pre-bend. I didn't use the the PCB to do that for it. And then all we'll need to do is screw in here, and then that runs out and it joins my barrel connector here, which is then hooked into the power. So this power is spliced between this barrel connector, this connector here that will eventually go to the lights, and the NodeMCU board. And then the data is only connected between the board and the chip, since it doesn't need to go in or out the thing. So I'm going to screw this in and close it up and get her going. Alright, so the last thing I'll have to do before putting the NodeMCU locked up is flashing the firmware. So all you have to do is load up the sketch. That's the Moodlite.eno sketch in there. We'll have to install a bunch of libraries like Fast LED, and then this ESP2066 group. Then with Board Manager, you need to add a new repository, links in the description, that has the ESP, and then select these settings here. So the ESP-E12E module, upload speed is fast or that speed for me, CPU frequency, and all these things that work for me. I didn't choose pretty much everything. Make sure you have the right COM port. Change the things you want to change. So I'll be testing out 4 tiles this time, so that's how many tiles I have. And all you need to do is hit that upload button, and it should come down here, and you should see it flash. And yeah, there's the frequent flashes that shows you that the board is flashing.